Okay, so morning everyone. I do the project proposal presentation for the Team2, which consists of Yonki, Tahir, Dongjae, and me. So we're going to talk about what we're deciding to do, what exists, and how we're going to do it, and the jobs and allocation and schedule. So our subject is about health condition. We want to predict health condition based on your blood pressure or your pulse or anything, and all this measured by a smartphone. So actually we thought about this because heart attack is a very common cause of death, and there's like every 34 seconds someone dies of heart attack, and it's the #1 killer in America. So, and the reason is sometimes because of heart disease and sometimes because of blood vessel disease. And we can easily find blood vessel disease by blood pressure or your pulse or anything. And one of the main causes of heart attack is a coronary heart disease, which is a blood vessel disease. It's when you have plaque builds up inside your arteries. So it reduces the flows of blood inside your arteries, and so you have less oxygen, you have a bigger blood pressure, and so this can they can block the blood flow, and you can create a heart attack or So we want to measure with the smartphone your heart rate, your blood pressure, and predict if you have higher chance or not to have a heart attack. So we did some background research, and so that's one paper, and there's also existing solutions. So they can. It's about there are a lot of different approach. There's one about data mining, so it's just having a lot of data about people who have disease, childhood pneumonia disease, and just watch the pattern in the data to see what are the main reason of this disease. And there are also some other application, and we want to add our project in the same table. So we have at the end we would like to have our project which use smartphone and deep machine learning to see if you have any chance to have or higher chance or higher risk to have any heart attack. So there's already had a similar projects using machine learning. So but they don't use smartphone and everything, and they haven't finished into an existing system. So we looked at them, and we thought about our own design. So we want to collect data from research and from big data which are already existing on the internet. So based on those data, we want to know what are these what people the typical blood pressure and typical heart rate and typical behavior of people who has higher risk to have heart attack. So we want to use those data to build our machine learning for the model to learn the pattern, and then we want to use the smartphone and and your own data to predict if you're good or bad, if you have higher or less risk of having a heart attack. So that's the training data we found. It's South Africa data, which with consent for 162 males, and there has a lot of data values, but we would like to concentrate only on 4 of them because we cannot learn about all of them. So, like blood pressure, which is the one we want to measure with your smartphone, and family history, heart disease, obesity, and age. And so to have to measure the data on your smartphone, there's not like one sensor on your smartphone who already can measure your blood pressure. So we looked on existing application who can calculate your blood pressure, and so there's iCare, which is only used like only the smartphone is needed. It's use the camera, the flash, and your pressure on the screen. So iCare is quite interesting, and you can have and it collects all the data, blood pressure, heart rate, oxygen, and everything. There's also Google Fit, which is more famous and maybe more maybe more used, but you need to have a special watch or some other device in order to capture your blood pressure and everything. And Samsung, Huawei, all the makers also have their own app, but this is not very useful for us because you have to build and you have to change your application for each smartphone maker. So we want to use iCare because you can have a lot of data. So it's the French screenshot, but so you can have blood pressure data, blood viscosity, heart rate, oxygen data, and so you can collect them. So we want to use an application to collect them and see if you have higher risk or not to have a heart attack. So our goals, the main goals are to build a machine to do the machine learning with the existing database we found. So we want to have TensorFlow. We want to have a relationship between like the physical condition and the disease. And the second main goal is to collect the data from your smartphone and predict on the computer if you're going to have, with the TensorFlow, predict if you have health condition is good or not. And we would like, if we have time, to make an application out of this. So that means that we have to input the TensorFlow program into the application. And we also want to see if, because we will only choose one method of machine learning to do the main goal, but we would like to see if there's like any other method which could be better or not. We still haven't decided which method we're going to use, but we would like maybe in additional goals to see which one would be the best. So this is our job allocation and the duration of each of task. So we can make a schedule. So we divided the in a preliminary work, such as benchmarking the existing system and research about health condition and disease relation, and about the smartphone sensor research, and also the model we want to make. So each person from the group had his own work to do, and then we would like to two of us do the Android program to collect the data, which is going to be a bit difficult because we have to collect the data from another application and not from a sensor from the phone. And two other people going to work on the TensorFlow program and the neural network learning. And then we want to combine all of them, combine both of them, and have a real health condition prediction. So everyone will work together on this. So our schedule. So first, now we are going to do all the research and benchmarking and model design, so we can start the Android program and neural network learning. And we hope that in the mid presentation, we will have an Android program starting to work, and that we have the TensorFlow program already done. And then we have the rest of the semester to finish this and do the final presentation. So, do you have any question?
Question from another team.
More clarification. So basically, you use your smartphone to measure like your own blood pressure and all the data, and then you compare with all the database.
Yeah.
So basically, you analyze just one person.
Yeah.
Okay.
But you can do, if you're not, maybe we can have different. You can measure your blood pressure a few times to check if the result is okay or not. But it's not. You will not use the smartphone data to do the machine learning. We use existing data to do the machine learning.
Yeah. So basically, you don't extract so many data from the
No.
smartphone. It's more like working on the machine learning.
You extract like 5 data to have like the health condition, but we do not extract like 1,000 data like you do. Yeah.
Okay.
Just out of curiosity, you are going to use IKEA?
Yeah, I think.
I saw blood elasticity or something like that. How can you get those data? I mean, oxygen, like viscosity, how can you get those information from the smartphone?
My phone is I can show you if you want, but actually you just put your finger on the camera and the flash is on. So actually when you press on the camera and the flash on, you can see like inside your your finger.
Image is coming from image.
Yeah.
It's called photo. It's based on photo.
And you also have to put your pressure another finger on the screen at the same time to have like the same pressure so they can compare. I don't think it's not as good as the blood pressure you can measure here, but it's something, and actually the results are very correct. I mean, that's the normal. I'm okay. That's the normal.
Aside from these blood things and oxygen, what else can you consider as an input or training of the machine learning?
We can input like your weight or your age, and we can add like that's the training data. We cannot choose anything in this, but we choose to only have the blood pressure, and if like you have your parents or grandparents had heart disease or not, and your weight and your age.
Okay, 28.
So your data set is coming from software first.
It's because it's the biggest data we found and the most accurate one, actually, because it's using the blood pressure, and it's not easy to find so big data about this. So, and actually South Africa is mix of, there's, well, not a lot of Asian, but there's a lot of European and African, so it's something, it's, yeah, different type of, I don't know how to say this.
In is there any kind of similar ability in eye care of treatment already?
To say if your heart rate is okay or not? Like to say, they don't say anything, they just give you the data and you have to see if it's okay or not by your own. They don't say like you're a good condition or not. They just say, yeah, they just measure and say do sport, but to everyone. So, yeah.
When you're analyzing the data set, so which kind of conjure times, what is it trying to find? Just the heart disease?
It's not find the heart disease, it's just if your blood pressure is a bit too high and you also have like heart disease present in your family, then the app should say maybe like you have a high risk of heart attack and be careful and maybe eat more, I don't know. But yeah, it's, we are not doctors, we cannot say like you have this heart disease, but we say like the risk is high, maybe be careful and check, and it's to prevent. It's maybe it's just like to, yeah, to say go to see a doctor or go to see a,
like I asked in the previous thing, I just want to know what are the given variables and what are you trying to find?
the given variable will be blood pressure on your and collected on your data, and you also have to because we asked for the age, so you also have to input your age and weight and family history, like yes or no if there's present, and the output would be good condition, bad condition.
Binary?
Yeah.
These systems enter your condition. So, and then you go to the hospital or the clinic. If you think about it, every morning you check your condition. This is for the ready to go hospital average. So that check.
Gives you whether it's dangerous or not.
Yeah.
Just tells you.
Up to now. If you want the complex, then you can.
Mm.
Right. Can be also another interesting project. Can I see the slide for Google device?
The eye care.
I can, and there's 3 options, right? Yeah, this one. You said you need a special device for Google Fit, right?
Yeah, you have to, the connected, it's not the watch, but it's a connected device which can you put on your arm and can
Do you know the
detect
price of the correct device?
around a few thousand euros. I think 100 euros, sorry.
100 euros.
Yeah.
Because the previous team says they will collect data every minute, right?
Yeah.
But I guess I care
No.
Frequency of
No, because you. No, yeah.
you need to say using image photo, so it can be hours, right?
Yeah.
The frequency of data collection can be hours. So if you need money or to buy the device for Google, I can provide money. It is less than $1,000. Because I hope you can do more frequent data collection
Okay.
to make out real-time learning system similar to the other one. But think about it. I can provide
Okay.
under $1,000, right? To increase the data frequency. One more thing is about your schedule. I hope it can be better to tag names of the
Okay.
worker segment. But you have another one, right?
Yeah.